Thanks a lot for joining today on the webinar series for data center networking. We're going to talk a little bit about VXLAN EVPN, what is going to happen very short term, what is going to happen very long term, meaning within this year. My name is Lucas Kradiger. I'm a principal engineer working in the technical marketing, and I hope to guide you a little bit through to that journey for the next couple of minutes or up to the top of the hour. Whenever you have questions, please ask them in the QA panel. We try to answer as much as we can. Maybe we stop somewhere as we go through. We'll answer some verbally or so on, but please use the QA, not the chat window for doing the question and answering there. Thank you very much. So with this, we're going to talk about things which are not released yet. So there is a roadmap disclaimer on all of these slides. Please be cautious in sharing them with your customer as the roadmap might change, delivery dates might change, feature function details might change until FCS first customer shipping of the release or the GA of the release at that time. So if you want to share anything, reach out to us. We can make sure that with your customer, with your NDA, we are going to go into the detailed discussion and share this information. On top of that, some of the things you see here are in EFT, an early field trial already right now. If there is any interest of early field trial on some of these features or functions, please let us know, and we can get you in touch with the PM team so you can subscribe your customer at this time for this release, just upcoming right now, or for a future EFT as needed. With this, let me go a little bit into the agenda of today. We have two main topics which we want to cover here. One is VPC, Virtual Port Channel Without Peer Link, which is one of our major achievements which we're going to release very, very soon. The second part is a little bit more about an outlook over the next 6 to 9, or maybe even a little bit beyond 6 to 9 months, on some of the high-level topics we are seeing focus in, and some of the background information on what we are intending to do in that area. Part of it committed, part of it still on the radar side. So as said, the roadmap disclaimer, I want to make sure that we all understand that piece, and you get early information, as we always try to give you, but we also want to be cautious on giving them too early without necessary commitments and so on. All right, so let me dial in right away into the VPC and the removal of the peer link, the physical peer link in VPC. We're not exactly removing the peer link at all. We're actually making it virtual, and you will see that in the upcoming slide on how that looks like. Now, when we looked at the environments of multi-homing in the industry, and when we looked at the journey we did with VPC, the virtual port channel infrastructure, we saw that we have a huge headway against the rest in the industry in order to deliver not only capabilities, meaning functions and features, but also scale and convergence in these areas. So when we put out our lay of the land in order to progress through new endeavors, new functions, we had kind of the following key objective in that specific regards of the feature here. The first one is we want to enhance the current dual homing solution as it stands today and make it more viable, make it more applicable to various different use cases. On top of that, we wanted to reduce the overhead of the dedicated physical ports we have to occupy today when we do all of these VPC infrastructures. Now, you might remember that in many of the best practices, many of the discussions, we say you have to accommodating the bandwidth of the uplinks for the physical peer link ports, but where it mostly ends up is in a pair of ports, which is the minimum in that port channel, which we call the VPC peer link. So we wanted to reduce that overhead, that math, that thoughts and dedications, and made that also simpler in that sense. The other thing is we want to preserve most and all of the desired characteristics you have there, which is in wide deployed VPC. We know that adoption of new technology always takes quite some time, depending on customer segment and as well as geographics. But the most of these time is learning new technology, how it behaves. So we wanted to stay on the characteristics of what VPC brought and expand on that and enhance on top of that. Last but not least, we wanted to optimize the traffic flows. We want to simplify some of the configuration items which are needed in order to get more optimal traffic flows. And with all of these key objectives, we jumped right away into the virtual peer link for VPC, or VPC without a physical peer link. Now, before we go through that, I want to make sure that we understand all, and I'm sure most of you do, the terminologies, the different namings and verbiage within VPC itself, and that's why I'm giving here a little bit of a recap on the traditional VPC. What you can see here in the center of this slide is you have two VPC member switches. We call them this way. I named them VPC1, VPC2, which are surrounded by what we call a VPC domain. So they belong to the same VPC domain, and they have a peer link in order to synchronize the state information between these two switches from a MAC, IP-ARP, IPND, and so on and so forth. As said, today this is a physical peer link as it stands, and in addition, in order to accommodate way further failure cases than other MCLAC solutions do in the industry, we added what we call the peer keep alive and separate that in order to make sure that in case of Bridge plane scenarios where the physical peer link is being completely interrupted, we still have a control plane channel between the two nodes in order to accommodate certain preventive actions for creating network loops. Further things is the VPC, the virtual port channel itself, where you see the server in the middle being connected with a port channel, individual ports, and a port channel, and the VPC attached to it. This makes basically the dual homing of that server possible. The other servers you see here on the slide on the very left or very right, we call them orphan hosts connected to an orphan port, and the orphan port has a slightly different characteristics than a VPC port. As one, it's only connected to one of the VPC port member rather than in two, and it's also not really considered, if not specifically treated by VPC in order to stay up or stay down. So these are the orphan ports there. As we know now a little bit of the terminology and the environment of VPC, I want to go further and discuss a little bit on what has happened when we did and introduced VPC for VXLAN. At one, we created in that VPC domain construct that notion of an Anycast VTEP. So instead of having these switches being completely autonomously from a data plane perspective, we combine them from a data plane and call them both together with the same identity with a so-called Anycast VTEP or a virtual IP address. So both of these switches are actually to the rest of the VXLAN network behaving as one asset from the VXLAN data plane perspective. Now, still, the switches are completely individual in identities when we look at it from a control plane perspective. So for example, in VXLAN EVPN, these are individual route distinguishers. As you can see them, they're different routing peering, so they're not like a combined single data plane and control plane notion. It's combined data plane, separated control plane. In that first iteration, in that initial iteration of VPC, we had a very simple set on how we advertise connected hosts and networks to the rest of the VXLAN or VXLAN EVPN network. Regardless of how we attach the host, is it to a VPC or is it orphan, we always advertised these hosts with the virtual IP address with the Anycast VTEP address. As a result, as you can guess, if traffic is coming from other switches, from other servers to VPC1, and we have a destination of the server on the very right side orphanly connected, we would have to cross the peer link, as it's still these orphan servers left and right are represented by the VIP, and the chance of hitting the right server is just by the ECMP hashing on the original source address there. So we had some kind of situations which are not most efficiently on top. Other parts which happened with this additional link we have between the switches was ensuring that a node is not completely isolated if all the uplink failures are happening. So we did a backup routing over the peer link in order to ensure that if VPC2 loses all the uplinks, the attachment for the server on the right-hand side or for the VPC hashing going to VPC2 is still able to encapsulate and reach all the rest of the network. So kind of the encapsulation part from the south to the north is not impacted by any uplink failure. This is required as the uplinks to the spines were not tracked at all. They didn't told us about we're losing the uplink information at all, and the signalization to the downlinks were not present there. And the backup routing over the peer link was a fantastic way of accommodating and improving that use case without adding complexity of new knobs and features. When we moved slightly forward and went from the traditional leaf and host attachment into the subnet attachment and the whole discussion on how networks are being attached, slight additional points were coming into discussion. VPC itself is a layer 2 redundancy, and as a sync in VPC, we are only using the synchronization of MAC, ARP, and ND information. Now, as you can see here, the subnet X on the left side and the subnet Y on the right side would not have been exchanged at all by the VPC concept of all, neither by CFS, which is running over the peer link or the peer keep alive messages. It had to be specifically extended between the left side and the right side, and for that you were required to do a per VRF peering, meaning a dedicated peering for each of the VRFs you have hosted on VPC1 and VPC2 in order to synchronize the control plane. As we went through the iterations through the days, about a year ago, it was in the 703 i7 release, we wanted to overcome some of these shortages, some of these additional complexity and scale implications, and we introduced a feature which was called Advertise PIP. The PIP is in its essence is the primary IP address or the personal identity, the individual identity the different VPC member have, and we enabled a function with this Advertise PIP feature in order to use local attached networks to be now advertised with the individual addresses rather than hiding them behind the virtual IP. This allowed us that traffic coming from the north side behind the spine from remote VTAPs going to subnet X or subnet Y were directly directed to the proper VPC1 or VPC2 kind of node rather than balancing it somehow to VPC1, VPC2 with the VIP address as a destination and then going over the peer link, which is again one of the objectives we try to remove and reduce as part of the virtual peer link function. As you can see on the bottom right, I show there our Advertise PIP feature we introduced back then. We only treated the type 5s, the IP prefix routes in EVPN. So we basically said that everything which is learned over a control plane will be advertised by the individual IP address, while everything which is directly and locally connected to the switches, i.e. the hosts, the servers, either VPC or Orphan, will be learned by the virtual Anycast VTAP and again is resolved to the balancing. Now, all of this in mind, this short recap over the last probably, I think it's 8 to 10 years when VPC was initially introduced and then subsequent VXLAN came in, VXLAN EVPN came in, and the enhancements on top of that, we're now at a stage where we want to take multiple of these key objectives and address them all at once, and we pack them into our VPC solution without any peer link, or VPC Square, how I tend to use it, and this is primarily addressed for the VXLAN EVPN environments. So when we look at how this is going to look in regards of the topologies and the functionalities, you see again there's a VPC domain, we stick to that, it's 2 VPC member in this domain, and you still see a VPC peer keep alive. What is changing is you will not see a physical peer link between VPC1 and VPC2. We are creating a virtual peer link over tunnel technology over all the available spines. The downstream connectivity for Orphan ports and VPC stays in its notion from how I attach and how I connect them to the VPC domain, either dual attached or single attached, but the connectivity between the devices, between VPC1 and VPC2, changed quite slightly. Now, to talk a little bit about the peer link. as said, the peer link is removed from a physical perspective, but there is still a virtual peer link actually in existence, and that virtual peer link is being treated over all the available layer 3 links you have towards the spine. So with 2 spine, 4 spine, or whatever number of spines you have in your network and the respective connectivity you have from VPC1, VPC2 to these different spines, we're using all these available layer 3 ECMP links in order to extend the virtual peer link. So we're using all spine, we're using them for redundancy, for resiliency, as well as for performance and bandwidth availability in order to use it instead of a dedicated set of infrastructure you have to account for at day one. Also, we are not using the VTAP infrastructure, so we are not using the VXLAN, VTAP IP address or loopback itself. We're using a dedicated loopback. Is it the router ID or is it the a dedicated loopback you configure in order to achieve the routing over all the spines between these two nodes? Again, redundancy, resiliency, bandwidth, and performance are key criteria in this area. As I said previously, the peer keep alive saved us in many, many cases where other vendors in the industry had challenges to accommodate split brain scenarios, and that's why we are remaining with the peer keep alive. Yes, we remain it, but it doesn't mean that you have to stick to an out-of-band management zero approach or a dedicated link in between these systems. You can definitely use that, which will probably still be our best practices to keep the peer keep alive separately or in addition redundantly from the virtual peer link over all the spines, but it's equally supported to do it over the out-of-band management or out-of-band port management zero or dedicated link, as well as about in-band, meaning using all the spines you have available. Now, one important thing is which I highly recommend and highly actually even would say require there is that don't use the same loopback for the different function, as you might have a routing impact, you might have a route advertisement impact, and the peer keep alive is only as good as the reachability is as good between these two VPC nodes, and the same is also true for the virtual peer link. So make sure the resiliency and the ability to have a source and have destinations between this all different paths is given. As well as hosts, we are all the way fine to do the orphan port connectivity for subnets. So you see subnet X, subnet Y, you see server on the left, server on the right, as well as the VPC dual homing fully supported in these kind of cases. A little bit of overview to the pieces which are key to some of them I said, some of them I didn't, but I wanted to call them out here specifically. We're going to introduce this as part of NXOS 9.2.3, and we will have that as part of the Essentials license, same as the VXLAN EVPN function already baked together. We will support this for the FX and FX2 based platforms in the 9.2.3 release. And we are working on the plan for the EX-based platforms, which is probably looking somewhere in, let's say, middle of the year to be cautious enough on this kind of area. We're going to support BUM replication for the underlay with PIM ASM as ingress replication, so there's no strong dependency. If you have a favor for ingress replication, the slight inefficient way, or PIM ASM sparse mode, the more efficient way. And in regards of PIM BIDIR, the bidirectional PIM, we are also supporting for BUM election as a TBD, which we will close before the FCS of N923 to make sure that it's clear if it's supported or not. We will also support TRM at the very first release with this. So we will have layer 2 unicast, you will have layer 2 BUM, meaning broadcast, unused multicast support. We'll have IPv6, we'll IPv4, and we will have IPv4 multicast as the final part there, where my IPv4 multicast will be PIM ASM as well as PIM SSM for the overlay. Now, a little bit of a sour drop, if you want to, or a little bit of a heads up there. We will, at the 9.2.3 release, only support a smaller VTAP scale. You know we are having today a 256 VTAP scale per fabric support, and at the initial release, we will give about a third of that when we are releasing this. The reason is when we are going in this always PIP mode, we actually have 3 VTAPs instead of just 1 VTAP in the VPC domain. So we are actually tripling the amount of taps in the overall network when we are going out with these kind of first initial release. But nevertheless, we are working on the compensation for this. We are compensate in the upcoming VTAP scale increase, which we are focusing for the 9.3x release, which is the mid-of-year release, in order to go back to the more commonly known 256 kind of VTAPs in your network, and as I said, compensate that scale if you want the deficiency or that scale reduction, which we have in the initial release. We're going to support the leaf case. That's mainly the host attachment case, single and dual, as well as the border deployments. So we're doing the routing type 5, external, internal, and so on and so forth, fully supported in these deployments at the very first day, but we're not going to use the border gateways for multi-site. Reasoning is twofold. One is we have an Anycast border gateway, which is a shared nothing approach already today, which we can go up to 4, subsequent even higher for multi-site, and the VPC were mostly relying on the legacy network integration there we still should be okay on some of the trombonancy which we might see in this. If you have a strong case for expanding the VPC border gateways as well without a peer link, reach out to us by email, over the mailer, or over the QA. We will happy to follow that up and see your use case and look into that. As for fabrics, we're always trying to de-emphasize a little bit on the FEX side. We will not support FEX at the very first release there. We are considering if you're doing FEX or not, same as for other features as well. So again, if you have a strong case for FEX in here, let us know. We are also working in order to overcome the FEX kind of attachment and kind of a second tier leaf, meaning a leaf, southbound of a leaf, which you can do already today. Is it in either VXLAN, EVPN standalone, or in certain other technologies as well. A little bit of the configuration. We stick to the VPC domain configuration and the port channel configuration mode. We stick to the VPC domain with a member of 2 in there. We stick to the interface port channel, which you see here in the VPC peer link definition. Now, 2 things change. In addition to the peer keep alive, we now add a virtual peer link destination and source peering, which you see has a different IP address as the keep alive in here, and it will also have a different IP address than your VTAP there as what you define them. So this is basically the main addition when you're going into the configuration of a VPC domain without peer link. The second piece of importance here is that the port channel, here port channel 500 as the VPC peer link, will stay existent, but it has to be removed of all the physical members in order to create the virtual peer link command in the VPC domain. So basically, everything looks the same from a high-level configuration perspective, apart from the VPC peer link has no physical ports, and the VPC domain has an additional command for the peering over the uplinks, over the spines, in order to go left and right there. Now, you also see there a DSCP marking. Here's 56. We want to make sure that the control plane messages are resilient enough. Yes, we have the distribution of ECMP. There might be also an in-time delivery, which could become important. So the DSCP marking and respectively potential QoS configuration on the spine is something to consider and something to implement at your needs are demanding this. Next to that, there's not much to add here. You see here also, this is the same leaf as you saw the VPC domain before. You see here my interfaces to the spine, and in order to tell the topology information to VPC on what is an uplink, we introduced the port type fabric to give the virtual VPC, the virtual peer link VPC infrastructure information on where to send actually this tunnel information to. And you will see you can define all the information on the very first slide if the port type fabric is not on all the uplinks towards the spine on these VPC nodes. You will not bring up the VPC domain as a result.
Similar as for the tunnels with VXLAN, which might require Jumbo MTU or might not require Jumbo MTU, consider that you're using the spine uplinks. If there is any requirement for Jumbo MTU over VXLAN or over the virtual peer link, then please accommodate the maximum MTU you require plus the additional overhead you need for the VXLAN encapsulation, in that case 50 or 55 bytes, to the uplink systems. In our case, we just do 9216, which should accommodate for all of these 9,000 plus the overhead easily. A little bit about the how we attach and how we look at it a little bit differently from how hosts being treated when we're going into the peer-link-less or virtual peer-link VPC infrastructure. Now, as said, we're multiplying the amount of VTAPs here, as we now have actually 3, or we divide the scale by 3 based on that infrastructure, as we now have individual VTAPs on VPC1 and VPC2 named with individual IP addresses, as well as we keep the virtual IP address, the Anycast VTAP, across the two. The difference here is that if you're attaching a host in dual, meaning to both, we will stick to the virtual IP address as the advertised next hop, but when a host is connected only to VPC1, we will advertise that host with the individual IP address of the VTAP of VPC1. As a result of this, you will see how the traffic flows will become much more efficient, and also some of the orphan-to-orphan communication will become much efficient and relaxing the requirements of transferring data over the peer link. Similar on the orphan, we are following the advertised PIP model here. It is a knob to enable. We would highly recommend to enable that, so you have also the communication from subnet X being advertised by VPC1, subnet Y advertised by VPC2. And you will see in a second on how that actual result will be if you enable these knobs and using the virtual peer link VPC infrastructure by helping for horizontal data flows as well as north-south data flows to be becoming more optimized. And here we go. You see, in this case, communication from remote switches coming in over the spine, and depending on what actually your destination is, you will use the right switch in order to reach that. So let's say we want to reach subnet X. Subnet X will be advertised with VPC1. That means we're going directly for VPC1 and do the decapsulation. Similarly, if we want to reach the server on the left-hand side, orphanly connected, we will directly reach to the server over VPC1. In cases where we have a dual attached server, we will use the virtual IP address and we'll use the ECMP hashing to VPC1 and VPC2 to efficiently distribute the data as well as reach the server directly where it is being connected, in that case dual homed. That's only one side of the story of the attachment-dependent advertisements we're having here, but it becomes way more obvious that in this case, there is actually no peer link in any steady state even necessary, and that was one of the key objectives we had it, removing the requirement for the bandwidth, removing the requirement for the need of any direct connection in order to offload these kind of redirection communication pieces. So let's look at what we're doing with the optimized traffic flows in a simple east-west in the same VPC domain. When you remember my slides earlier, subnet X to subnet Y went over the peer link and it needed an active synchronization of the routing table. When we're going now into VPC without peer link, as we advertise subnet X by the individual IP address of VPC1 and subnet Y over the individual IP address of VPC2, we will use VXLAN EVPN-based forwarding to A, receive the control plane information, and B, do the data plane forwarding. So subnet X goes to VPC1, we will do an encapsulation towards VPC2 or VXLAN EVPN over all the spines, and then decapsulate on VPC2 and respectively reach subnet Y. That was not available in the today VPC infrastructure with the peer link. Also, communication to orphan hosts or from orphan hosts to networks. You see here subnet X to the server on the very right side, as they are advertised by the individual IP addresses of the respective attachment point, we can use the VXLAN EVPN forwarding over all the spines in order to have communication left and right. Other case, orphan to orphan, a case which today was always over the peer link. We're using here all the spines, so even if there would be a link in between, we will still use all the uplinks, we will still use the spine links, we still use the VXLAN EVPN forwarding, so we will not going and tie into the peer link function at all in any of these models you just saw here. Failure cases, a little bit about that. I said we have a server here, orphan connected. We have a server here, dual connected, and dual connected loses the local link. In the normal cases, if the link would not be disappearing, the X link here, we would go server VPC1 directly to server connected there. But in this case, we will reach from the server VPC1. We will see it was a dual attached server here which lost its connectivity directly. It will only see the information over the virtual peer link, so we will do and bounce over the virtual peer link over the spines to the other side. Now the importance here, this is kind of using a different layer in the forwarding story. You remember me saying before we're using VXLAN EVPN for all of these orphan to orphan communication, but for the orphan to VPC attached, we would normally stay local as the VPC attached server is dual connected in these cases. For the failure cases, we're using the bounce over the virtual peer link visit, which is pretty much one of the only cases where we're using this peer link function. Similarly, coming from the external world, we would still come over the spine, and as the server in the middle previously dual connected, was advertised by the VIP, it could hit VPC1 or VPC2. If it hits VPC2, it's great. The downlink is still there. We can still reach over VPC, the server, which is dual connected there. But in the cases where we have hitting VPC1, we would decapsulate and we would not have a route going to VPC2. Instead of that, we're using a bounce, the bounce capability of the virtual peer link and sending it over to VPC2. And again, in that case, in these failure scenarios, that's one of the cases where the virtual peer link comes into the game for the horizontal forwarding between VPC1 and VPC2. Now, I said we are compensating for more VTEP scale in than the subsequent releases, but we're actually introducing a little bit higher scale of VTEPs already in the 9.2 release. In the 9.2.3 release, the same release as we do the virtual peer link VPC, in order to ensure we are ready for the upcoming releases to compensate for that scale. So we're increasing the per fabric VTEP scale here, the NVE peers, and we are increasing it for various different reasons. We are not increasing it to get a larger fabric scale. We still think multi-site is the better way to scale larger networks with control, but there are need for compensation by the increased scale we are going to provide for multi-site, as well as previously mentioned, the VPC without peer link, which is now 3 VTEPs instead of being 1 before. Last but not least, in this area of the 512 VTEPs, we're focusing on a unidimensional scale here. So we're trying to be very specific to the use case where the 512 VTEPs fit in there, which is slightly different than just what we did with the 256 so far, which are tested fully in a multidimensional scale for fabric functionality, meaning having a lot of different functions on the switches itself. All right, that was the first part. Is there anything in the chat window which might be interesting here? Let me read one or two of the questions. Can a virtual peer link coexist with physical peer link? Said virtual peer link is used as backup for physical peer link. No. So the environment is either in virtual peer link mode or it's in physical peer link mode. As you have multiple uplinks towards your spine, you already diversify and have additional redundancy there, so you would not have the possibility to add a peer link there. That would also be very, very complicated in dealing with a port channel which has physical and virtual member. You probably all remember that port channel has some strict requirements there, so that would not come in the equation here. Regardless of that, I wanted to say that if you have an infrastructure which has a set of switches, a couple of VPC domain in virtual peer link mode, and actually you have a couple of VPC domains which have peer link, they can coexist in the same fabric as long as they're not sharing the same VPC domain together. So VPC domain is either in virtual or physical peer link, but within a fabric you can have a mix of virtual and physical peer link, which is again one of the criteria to using this kind of technology, as going into a different kind of multi-homing solution would require exclusivity by the technology used. Either I'm using another multi-homing solution, or I use VXLAN, EVPN, virtual VPC solution here. Now, preempt a little bit also on the questions here, as I was a little bit faster than this morning here on this webinar. So right now, the primary objective to deploying this is in having it in a VXLAN EVPN environment. Now, it's not completely excluded from the possibility that we're expanding the legacy Ethernet VPC technology also and removing the peer link. Now, this said, it would require that you have routed uplinks from the VPC domain to reach from one VPC member to the other VPC member. Now, in a classic Ethernet environment where you have a VPC domain, you have host connectivity to the south, and you have to the north also an Ethernet connectivity, you would have a lack of routing capability for that connectivity for the virtual peer link. So that will kind of be the challenge there. But we're considering certain variations on how we can deploy there. But as it stands today, the primary focus right now is on the VXLAN EVPN and using the layer 3 routed infrastructure to the north, the spine layer in that case, in order to forwarding. If you're in an environment where VPC is only used in the access layer for host connectivity, and beyond that everything is layer 3, there is actually possibilities and make that available already in the 923 release time frame. It's a little bit of let's call it a workaround configuration there, but we will come back with clear documentation on if something is needed like this, that we can accommodate these use cases either initially or subsequent. So reach out to us. We're happy to discuss these use cases there. All right. I hope we have a good set of points here in that first section. I hope it was excited to hear that we're really making progress and really going fast forward. And as said, the EFT for the VPC without peer link, as well as the 512 VTEP scale, is actually available right now. And I think our dear PM Shankar is on the call here as well, and he probably reads in the QA panel or reads in the chat panel if there is anyone interested on these kind of areas. With this, let me move slowly into the plan for the next 6 to 9 months. As said, I'm looking more at the things from a technical marketing perspective. I'm not want to give you just a roadmap update, so I want to give you some considerations in the background to these features we are working on, not want to discount all the work our PMs are doing. So we have one of the big ticket items for the mid-of-year release. It's the 9.3x or 9.3.1 release, is enabling tenant-routed multicast for multi-site. As you might know, today multi-site is available for layer 2 and layer 3, V4, V6. But if you would like to have multiple sites also exchange and multicast traffic in between, we would not have that capability as it stands right now. With the upcoming 9.3.1 release, or 9.3x release train, which is towards the mid of the year, we are going to change that. So we're going to add tenant routed multicast to multi. In the implementation details, the intra-site TRM part remains as it is today. We're not changing anything from a leaf perspective, so you have the ability to insert multi-site as a result there. You're just continuing your development, so we stay to PIM sparse mode or PIM ASM in that regards. When we are considering the communication between the border gateways and multi-site, we also wanted to stick on what we're having today, which is the intersite will be continuously used with ingress replication. That means we're running TRM over ingress replication between the different multi-site environments, between the different border gateways of the multi-site environments. Now, that has kind of two advantages. One of them is we will not need any multicast requirements in the underlay between any of the sites, so your core transport can be unchanged, and that's again one of the advantages we have when we are moving into an existing setup. The adoption of technology becomes easier by not changing the existing core infrastructure. The other thing which ingress replication gives us within the core is we can totally avoid of sending unnecessary traffic replication between sites. So let me explain that. If inside one I have a source and inside two I have a receiver, I obviously replicate the multicast traffic because it's needed. In the case there is a site 3 and there is no receiver or source which is interested in any of the other receiver or source in the other sites, we will not replicate any traffic there. We will keep them isolated. So it's kind of a subscription or pub-sub model, if you want, so how multicast works, efficiently implemented over the core, over the multi-site network in these cases. Rendezvous capability, we will stick to external rendezvous point as well as internal rendezvous point. We also have the the RP Everywhere solution, which became available later last year, which we are currently evaluating on how we're going to implement that part into the overall tenant routed multicast and multi-site there. Now, again, I mentioned before, we're working on scale items, and one of the scale items you saw is the 512 VTEP scale for the compensation of larger scale in order features. Now, one of these order features is multi-site, which we're going to increase to 6 border gateways in the Anycast mode. So today, we have 4 border gateways in Anycast mode, and now we're increasing that by 50% to increase to 6, which means the amount of border gateway peerings in the fabric as well as the border gateway peerings egress external to the fabric is increasing. The VPC border gateway, we stay as it is, so it's a pair of 2, and as said before, we stay with the peer link there. Reach out to us if you have interest on discussing the use case, why we should remove it up there, and we're happy to discuss. The other scale which we're increasing is we're going to 32 sites, and with the 6 Anycast border gateways and the 32 sites there, the amount of peerings in the data plane are actually increasing, and that's where the compensation comes in, where we're increasing the VTEP scale. So we're trying to stay in the site internal at the scale we have today, which is the 250 VTEPs, 250 plus the 6 border gateways, but we don't want to discount the leaf scale or the VTEP scale within the fabric from what we need in order to create that 32 by 6. And again, I did a stupid math here and just added some additional non-necessary there, but I want to be able to do 192 or the 190, approximate 190 peerings in the site external virtual multi-site, still keep the 250, which brings me close to this 512 we're actually going to achieve, rather than reducing the site internal to only 60, which is quite insufficient from a scale perspective. Let me see if there are any questions in regards to that. In the meantime, I hope we're all good. So we see. All right, just a question. How much of the traffic replication between sites was the problem? If you can quantify that, what specific problem does it solve besides kind of traffic cleanup now? Now, today we don't do tenant router multicast over multi-site, so there is no previous state which would say there was a problem before. The main fact is that the core networks, for example, in data center interconnect, are not the high bandwidth, high speed, X links kind of networks. So as a result of that, and when we have to accommodate to, let's say, 2 times 1 gig and just send unconditional multicast over, we will occupy the bandwidth just up front without having any interesting receiver on the other side. So we wanted to make that more conditional, to be cautious on the lower bandwidth links between the data centers, and that's where the optimization comes in, to only send if there is an interest on the remote side. I hope that answered the question in there for that specific QA question there from Sushil. The other piece we're working on is seamless handoffs or gateway functions between VXLAN data center networks and other network types or other technology types, like segment routing or just generally labeled technology. So what we're going to release in the 9.3x timeline is a seamless handoff between VXLAN EVPN and MPLS LDP with L3 VPN, as well as MPLS SR with L3 VPN. Now, some of you might be aware that the first line item, the VXLAN EVPN to MPLS LDP L3 VPN, has been done already on previous platforms like ASR 9K, Nexus 7000, ASR 1K. We're now going to expand that to other Nexus portfolio members, namely we are going to have the MPLS LDP handoff planned for the R series, which is kind of extending our investment into the Jericho-placed boxes for the DCI cases or the PE cases, as well as we're going to do the same thing for the MPLS SR, which also brings some additional feature for labeled segment routing to the R series switches. On top of that, for the SR handoff from VXLAN EVPN, we're also using the FX2 platforms. We're trying to position the FX2 as our go-to DCI platform with the capabilities we have in there for VXLAN multi-site, TRM, MPLS SR, as you can see here, and it's pretty versatile in what we can do with our own chips in that regards. There is also further work being there. You heard me talk about tenant router multicast in the beginning. I talk now about tenant router multicast again. We are working on the seamless handoff between tenant router multicast from a VXLAN EVPN network to the multicast VPN in the labeled space, namely MPLS LDP and Draft Trojan, in order to also have many of the universities requiring a multicast in addition of unicast L3. So we're addressing that use case in this area with the R series boxes primarily. Last but not least, it's all about IPv6. IPv6 is, in some regions of the world, a pretty critical area. It's some segments a pretty critical area, and we want to not consider that as a second-class citizen. We want to pick that up and drive also forward on what is happening in that area and what is demanded in that area. So we're going to release what we call VXLAN v6. It's basically VXLAN over an IPv6 underlay. So we're trying to not only just introduce IPv6, but also add some simplicity. If you think of OSPF v3 or ISIs using link local addresses for the routing and reducing the amount of configuration necessariness in that case. We're going to release it with ingress replication first, and we will go and subsequent release multicast-based underlay as well, in order to keep the efficiency and also to prepare for all the tenant router multicast cases subsequent. We will support IPv4 and IPv6 over VXLAN v6, in addition of the layer 2 cases, the bridging cases, which are agnostic to the IP addressing cases here. We will start with the VPC peer link for initial release, so we're not going to remove the peer link first. We want that the initial release to give us a little bit of air to see of how the initial release of VPC without peer link established itself, as well as then later the VXLAN v6 established, so we can merge these functional together and simplify on top of that to make that whole and as not a second-class citizen. Last but not least, we have a strong interest on delivering and releasing IPv6 multicast. It's probably more later this year or early next year where we have that, so that's why I put it on the radar. So we call it TRM v6, similar as VXLAN v6, kind of using an IPv6 infrastructure, as well as transporting the IPv6 multicast over the top in addition to the v4, which we already have available today. So with this, I think I nailed it pretty much from the timeline. I wanted to give about approximately 10 minutes at the end to scroll through some questions and go and see what we can answer, which hasn't been answered yet. So team in the call, panelists, anything we have to consider, anything which needs an answer? Karishma, Shruti, Nemanja, Sunil. I cannot ask Shankar. Nothing so far. Everything answered verbally. Everyone happy with the answers. Anything else which needs to come up? I guess you guys are on mute. Karishma, Sunil.
Lucas, yeah, I'm sure they are. I think we're good. We've answered all the questions so far.
All right, very good. And Shankar sends me a smiley, so is happy that we mentioned him like 100 times, and his emails are probably now, his inbox is going to explode for some of the features which are in EFT right now. All right, with this, Johanna, I made it a little bit better than this morning.